Okay guys, so I'm going to teach you about how to solve systems of equations by using the elimination technique. What we've talked about so far in class is basically like if I have an equation with two different variables and I just had one, I could not solve that equation. But if I have two equations, I could solve it. And just for your own knowledge, however many variables you have, that equals how many equations that you would need to be able to solve for each of those variables. So what we want to do here is we want to figure out the value of x and the value of y that satisfies both of these equations, that make both of these true. So there's this technique called elimination. And so what you can actually do is you can actually add these two equations together, and if you notice, a positive x and a negative x will cancel. Positive y and positive y is like 1y and 1y, that'll make 2y. And 83 and 7 make 90. And then I have a pretty little simple equation to solve. I would just divide both sides by 2. I get one of my values. To get my x value, I can substitute 45 into this equation and solve for x, or I could substitute 45 into this equation and solve for x. I'm going to use the first one. So x plus, instead of writing y, I'm going to write 45 equals 83. To get x by itself, I'm going to subtract 45 from both sides. That gives me, little mistake there. That gives me 38. Okay, so that's what we're looking for here, the value of x and the value of y. Alright, so let me show you another example. Okay, this time we have a fraction, so don't be scared. And this time we don't already have a pair of opposites. But another thing that I'm allowed to do with equations is I'm allowed to multiply by anything I want to, as long as I multiply it by each term. So in this case, I have a 6x and I have a 4y, so I would either want to multiply everything by -6 so that I create my pair of opposites, or everything by +4. But just looking ahead and thinking about, what's going to be the easiest option, I notice here that I have a fraction. The denominator is a 3, and I know that if I multiply by the -6 option, that -6 is actually going to cancel with my denominator of 3. So that is the option I'm going to go with. So I'm just going to rewrite this so that way we can refer back to the original when we go to solve for the other variable. And I'm going to leave some space to include my multiplication of -6. So let me do that in a different style of pen. Alright, so I'm going to multiply this by -6. If I multiply negative by -6, this is going to become a positive. And if I multiply this by -6, my 3 will cancel with my 6, and that will leave me with -2. Okay, so now I'm ready to add the two equations together. These cancel. This makes 10y. I'm going to go back to using my other marker. 22, this makes a -2. 22 minus 2 gives me 20. Divide both sides by 10. And y is 2. Now I want to go back to one of my original equations, either the one with the fraction or the one without. I'm going to assume that you guys would prefer to use the one without the fraction. So we're going to go back to that original and substitute 2 for y and solve for x. So I get 6x plus 8 equals 22. Then want to subtract 8 from both sides. I get 6x equals 14. Divide both sides by 6. I get an improper fraction that actually can be reduced. 14 and 6 are both even, so they're both divisible by 2. So if I divide 14 by 2, I get 7. 6 divided by 2, I get 3. So my solutions are x is equal to 7/3 and y is equal to 2. Okay, so that is that. Now let's look at the word problem. Okay, let's see what I did with that. All right, so here I have a word problem. This says, this is from my math lab, a restaurant manager wants to purchase 200 sets of dishes. One design costs 20%, while another costs 35%. She wants to use her entire budget of $5,500. How many of each design should be ordered? So remember that whenever I was teaching you guys about how to solve word problems in algebra, you have that 4-step process where you want to first define the variable, set up your equations, solve the equations, and then interpret your results. So my first step in that process is to define each variable. So I'm going to let x equal, notice they're asking how many, so I want to know the number of each set of dishes, and I'll call the $20 set the cheap set, and the $35 set we'll call the pricey set. Okay, so our word problem is going to give us 2 different equations. It has to, in order for us to solve the 2 different variables. So the first equation can come from the fact that we want to purchase 200 sets. So that means this number plus this number has to equal 200. Okay. The second equation comes from the cost. So the first design costs $20 per set. So we calculate costs by multiplying the cost by the number that we're purchasing. So our cost for the cheap set will be 20x. Our cost for the pricey set will be 35y. And we want that cost to be limited to $5,500, or to come out to be that. So we have this system of equations here. Again, we want to create a pair of opposites. I can multiply this first equation by -20 in order to create a pair of opposites with my x, or I can multiply it by -35 in order to create a pair of opposites with my y. I think -20 is a little bit easier to work with, so that's what I'm going to do. So if I multiply this first equation by -20, I get -20x, -20y. -20 times 200 is going to be 4,000. And then I keep the second equation the same. And then again, I'm going to add them together. So my x's will cancel. -20 plus 35 makes 15. -4,000 plus 5,500 makes 1,500. Divide both sides by 15. And I find out that I want to purchase 100 pieces of the pricey set. And if you kind of think about it, if I'm purchasing 100 of the pricey and they have to add up to 200, then I need to purchase 100 of the cheap set. But if that's not obvious to you, all you have to do is substitute for y and solve for x, and you get the number that you should buy of the cheap set and the number that you should buy of the pricey set. And that will be the choice that you select in My Math Lab.